This video is about normal distribution. One of frequency histogram of a continuous data is a bell-shaped and symmetric about the mean. We call it normal distribution. The normal distribution is the most important distribution for a continuous random variable. Here are some examples. Height or weight of a large population. Test scores taken by a large population. It will be normal distribution. The graph will be like this. For the normal probability density function, here's the one. X will be between negative infinity to positive infinity. We written as this. Read as X is distributed as a normal distribution. Let's talk about this curve. The curve y equals f of x, which is called the normal curve, is symmetric about the vertical line x equals mu. That's mean. As x approaches positive or negative infinity, the normal curve approaches its asymptote, the x-axis. For f of x greater than 0 for all x, because it shows the probability. Since the total probability must be 1, which means the area under the curve equals 1. Let's talk about geometric significance of mu and sigma. That's a standard deviation. This is the maximum point of a normal curve. The standard deviation is the point of inflection. For all normal distribution curve, this is the value for each interval. You need to remember these numbers. For a continuous variable, we can only talk about the probability that an event lies an interval. Therefore, this is equals to each other, which means x less than or equal to b greater than equal to a. You have another 3 ways to write. You will get exactly the same answer. More properties about normal distribution. Remember, the graph is bell-shaped. The highest point on the curve is at the mean of distribution. The mean, median, and the mode of the distribution are the same. The curve is symmetric with respect to its mean. The total area under the curve is equals to 1. Go to guided practice 1. The mean height of players in a basketball competition is 184 centimeters. If the standard deviation is 5 centimeters, what percentage of them are likely to be? A. Taller than 189 centimeters. Let's label this normal curve. From given information, we know the mean is 184. Then we keep adding 5. This will be 189, 194, 199. Then we keep minus 5, 179, 174, 169. Then you will get this will be 34.13, 13.59, 2.15, 0.13. Therefore, for the A taller than 189, you need to add all these. That will be 13.59 plus 2.15 plus 0.13. Then we put the percentage. Answer will be 15.87%. Check B, taller than 179, which means I have to adding these two to this taller than 189. Or you can use the probability when x greater than mean equals 50%. Therefore, you can use half of this, that's 50%, add 34.13. So we have 34.13 plus 50. You will get 84.13%. Let's go to C, between 174 and 199. Now let's use this diagram. 174 and 199, which means this area. So we add all these numbers between 174 to 199. 34.13 you multiply by 2. Then you add 13.59 you multiply by 2. So you get this 4 area. This part you need to add 2.15. So you get 97.59%. Last question, over 199, that is this number, 0.13%. Let's go to guided practice 2. The weights of adjacent origins are normally distributed. 84% of the crop weight more than 152 grams and 16% weigh more than 200 grams. Find the mu and standard deviation sigma for the crop. We need to check 84% of the crop weigh more than 152 grams. From here, this area, you will get 84%, because this 2 is 68.26 plus 13.59 plus 2.15 plus 0.13. It will be equals to 84%, rounding to 84%. Therefore, we could say this mu minus sigma equals 152. And also 16% weigh more than 200 grams. 16% will be this, because 13.59 plus 2.15 plus 0.13, it will be equals to 16%. Therefore, you will get mu plus sigma equals 200. You need to solve this system equation. Adding 2 mu equals 352. Mu will be 176. So we plug in to get the sigma equals 200 minus 176. You will get 24. This is the answer to A. For B, what percentage of oranges weigh between 152 grams and 224 grams? We need to label this normal distribution. We have 176. Keep adding 24. You will get the 200. 224. Then subtract 24. You will get the 152. So we are looking for this area between 152 to 224. So you have 34.13 times 2, add 13.59. Then you put the percentage. The answer will be 81.85%. Now, I will introduce the standard normal distribution. It's also called the Z-distribution or Z-curve. This is the notation. Here's the relationship between Z, mu, and sigma. For the Z-curve, the mean will be 0. Standard deviation will be 1. We call this is a Z-score. Then the probability will be the same as a normal distribution for each interval. So for the Z-curve, probability Z less than -2, it will be 0.13 plus 2.15. That is a 2.28%. For probability Z greater than 1, it will be here. That will be 13.59 plus 2.15 plus 0.13 equals 15.87%.